One of the most important theorems that the SAS congruency condition helps us to prove is the isosceles triangle theorem. Before we move on to proving it, we need to know what it exactly is. Look at the triangle ABC. These two sides are equal. Let's move the triangle to the left to understand the theorem. The theorem tells us that if side AC equals side AB, that is, if this side equals this side, then measure of angle ABC will also be equal to that of angle ACB. This angle, which is opposite to this side, will be equal to this angle, which is opposite to side AB. If the two sides in a triangle are equal, then the angles opposite them are also equal. How do we prove this? Let's move on to a new page. We redraw triangle ABC and jot down all the data we have. Lengths of these two sides are equal as it's an isosceles triangle. The first thing we should do before we prove something is write down all the data that has been given to us. We have been given that segment AC is congruent to segment AB. The next thing we have to note down is that we have been asked to prove. We have to prove that the angles opposite the equal sides in a triangle are congruent. That is, we need to prove that angle ABC is congruent to angle ACB. Looking at the figure, you would feel that we haven't been provided with any data. Then how are we supposed to prove these two angles equal? The best way to prove any two angles or any two sides congruent is by proving two triangles congruent. So they become corresponding angles and will hence be congruent. But here we have just one triangle and we need to prove these two angles congruent. In such cases, we make two triangles. We can do a bit of construction to help ourselves. Let's draw the angle bisector of angle BAC. We are talking about this angle. So we draw the bisector like this. Let this red dotted line be the angle bisector of angle BAC and let it intersect BC at point D. Measure of angle BAD will equal that of angle CAD. Now we have two triangles, triangle ABD and triangle ACD. If we somehow manage to prove that two sides and an included angle of triangle ABD are equal to the corresponding two sides and an included angle of triangle ACD, then we can say that the two triangles are congruent. After we have jotted down the data given and the to prove section, we go to the proof. We have to look at triangle ABD and triangle ACD. Have we been given any data about the two triangles? Yes, we have been given that segment AB is congruent to segment AC. Based on our construction, we can also say that angle BAD is congruent to angle CAD. Now this is interesting. We can see that this side is common to both the triangles. We can say that segment AD is congruent to segment AD since it is the common side. Guess what? We just proved that the two sides and the included angles of both the triangles are equal. Side, angle, side. We can say that triangle ABD is congruent to triangle ACD by the SAS axiom. This in turn tells us that angle ABC is congruent to angle ACB since they are corresponding angles of congruent triangles. We proved these two angles congruent. We used the side angle side axiom to prove the isosceles triangle theorem, which says that angles opposite equal sides are always equal.